Hello dear friends, welcome back to my YouTube channel. In today's lecture, we are going to learn about the oxidation number or the oxidation state 1. Remember student, this is very important term which is generally used in the chemistry 1. So in today's lecture, we will define the oxidation number. Now, what is the importance of the oxidation number and what are the applications of the oxidation number? In the previous lecture, we have defined the oxidation and the reduction reaction 1. Is it right? By using your electron transfer concept. So there we have defined the oxidation as a loss of electron. Is it right? While the reduction as a gain of electrons. Okay. By these two particular definition, we can conclude of one thing. That is nothing but whenever there is a loss or the gain of electron takes place, there is a complete transfer of electrons takes place. Is it right? And or in any chemical reactions, whenever there is a complete transfer of electron takes place, there is always formation of ionic compound 1. Is it right? Or that compound involves the ionic bond 1. But as we know that there are so many chemical reactions which involves a covalent bond also, okay, and that form a covalent compound. Is it right? Now, to explain the oxidation and the reduction process which is involved in your covalent compound, we introduce the new term, and that new term is nothing but your oxidation number or oxidation state. Oxidation state. Is it right? Now, remember this particular term was introduced for your covalent compounds. Okay, your oxidation number or oxidation state is generally described all types of the redox reactions 1. Okay, so your oxidation number or oxidation state involves the all type of your redox reactions 1. Now, which are the types 1? The reactions which involve ionic bond. Okay, ionic bond, and we know that in the ionic bond there is always involvement of complete transfer of electron takes place. There is always a complete transfer of electrons 1, as well as it involves the covalent bond. Okay, now in that covalent bond there is a shifting of electrons takes place. Is it right? So that's why we have introduced this particular term oxidation number or the oxidation state. Keep it in your mind while to consider the few example. If I am going to consider the example, formation of your sodium chloride. Okay, Na plus ion plus Cl minus ion gives NaCl. Is it right? This is very simple chemical reactions. We know that Na plus Cl minus gives NaCl. Okay, here you know that sodium ion lose its electron to the chlorine accept it, and there is formation of NaCl takes place. So we can categorize this reaction as a redox reaction, as there is a complete transfer of electron takes place 1. Now, if I consider the second example, that is 2H2O plus O2 gives H2O, 2H2O. Now here, remember this compound forms a covalent bond one. It is not ionic bond. Okay. And as we know that if that particular compound involves a ionic bond, there is complete transfer of electron does not takes place. There is a sharing of electron takes place. Or we now let us consider the third example. H2 plus Cl2 gives HCl, 2HCl. Okay. Now here also this particular compound, both this product involve a polar bond one. Okay, a polar covalent bond. Okay. And now if we have to apply the oxidation number concept to your polar covalent compound, we have the few assumptions one. Okay. Now let us consider that assumption and then we will discuss in detail one. Now the assumptions of your to apply your oxidation number or the oxidation state to the atom or molecule, it is assumed that first the electron pair, okay, the electron pair belongs to more electronegative element. That is our first assumption. Remember, these assumptions are for your covalent compound only. Okay. Now here the first assumptions, electron pair belongs to the more electronegative element one. That means what? There is more shifting of electron pair takes place towards more electronegative element one, more electronegative element. So that is our first assumption. Remember student, here generally in short we are saying that this electron pairs belongs to more electronegative element. That means it will contribute more in the covalent bond one. Now the second assumption that we are going to consider here, the covalent bond is always formed with heteroatom. Okay. Covalent bond is always formed with the heteroatom. That means what? The covalent bond will have a polar nature. One particular atom have a more electronegativity than the other. Okay. Now the third important assumption that we are going to consider, there is always ionic bond by loss or gain of electrons irrespective the actual nature of a bond one. So these are the three important assumptions to apply the oxidation number concept to your redox reaction one. Now again, listen it, very simple. Generally we considered that the covalent bond involves a more electronegative element and that electron pair belongs to the more electronegative element. So obviously, in short, we will say that the electron pair is contributed by more electronegative element one. That means the transfer of electron takes place by the more electronegative element one. Second assumption is that covalent bond is always with the heteroatom, and the third one is, that means what? That covalent bond is always with the heteroatom. There is always a one heteroatom in the covalent bond. And the second one is that, and the third one is that there is always an ionic bond. Though that bond is a covalent bond, but we are going to treat that bond as an ionic bond one. So these are the three important assumptions, and on the basis of that assumptions, we will study now this example. Dear students, now so first Na plus Cl minus, it is very simple. There is a complete transfer of electron takes place. There is formation of ionic compound. So obviously we can say that as there is a loss of electron from the sodium atom, it undergoes oxidation. Chlorine accepts the lone pair of electron, hence it undergoes the reduction. Now what about this particular two polar products one? Is it right? We know that H2O molecule, HOH, okay, and HCl. As we know that the electronegativity of oxygen atom is more as compared to hydrogen atom, okay, so they will have a partial charges, and now I have just written that charges one. Oxygen will have a del minus charge while hydrogen have the del plus charge. We know that this particular molecule consists of your covalent bond. In the covalent bond, one electron is contributed by oxygen atom and one by the hydrogen atom. Okay, so obviously there is a lone pair of there is a pair of electron which forms your covalent bond. But by studying these assumptions, we are saying that we know that already this bond is a polar bond, so electron pair is shift more towards the oxygen atom. So electron pair shift more towards the oxygen atom, and we are saying that this electron pair belongs to the more electronegative element one. That means there is a more electron density, there is less electron density here one. Okay. So chlorine is more electronegative. So whatever the contributing electron pair, it will be shift more towards the chlorine atom one. So on the basis of this particular three assumptions, is it right? Though this bond is a covalent bond, we are going to treat as an ionic bond one. If we are going to treat as an ionic bond, we can classify. So we can classify that particular reactions into the redox reactions one. Okay. Now let us define the oxidation number. Theoretically, how we can define the oxidation number one. So remember, oxidation number or the oxidation state for an atom or element in molecule or ion is defined as a hypothetical electrical charges. It is carried by that particular atom when a complete transfer of electron takes place one. Okay, so that is the definition of your oxidation number one. Now let us write it. Oxidation state or oxidation number or oxidation state for atom or element in molecule or ions is defined as the hypothetical means imaginary, okay, hypothetical electric charges it would carry if the electrons were completely transferred. So this is a definition of your oxidation number, a theoretical definition of your oxidation number. Now what you have to learn from this definition? Remember, oxidation number is considered as a hypothetical charge. It is an imaginary charge which is particularly exhibited by that atom which is in the molecule or ion one. Okay, and we considered this charges is because of transfer of electron takes place one. We know that electric charges are of two types, either the positive charge or the negative charge. When any atom which loses its electron will gain a positive charge. Any atom which gains the electron, it will exhibit the negative charge one. Is it right? So this is the definition of your oxidation number or the oxidation state 1. In short, just you have to remember, this is nothing but the hypothetical charge which is exhibited by the atom in the molecule 1. Okay, so this is about your oxidation state 1. Now again the question may be arise in your mind, why we are giving too much importance to the oxidation number, as we are saying that this is again the hypothetical charge 1. Remember student, now just revise. Previously we have defined the redox reaction by using our old and classical concept. Within that one we have used the oxygen atom also can be involved by using your oxidation number. Then we have learned the electron transfer concept also. So the electron transfer concept is also not neglected by your oxidation number 1. That we have learned can come under the oxidation state or the oxidation number 1. Okay, so this is the importance of your oxidation number. Thanks for watching this video. See you in the next video.